Welcome to lesson 7.2. We're going to be finding the slope from an equation. It's going to be pretty dope. Now, you might remember in the last lesson what we were doing was we were finding the slope from 2 points and we were finding it from a graph. Now, it's going to be finding slope from an equation. Now, let's just do a little bit of a review from last year, okay? This is going to be a review lesson. Maybe you got it, maybe you don't. If you don't, pay attention. We'll be able to find all those slopes from equations in just a second. But it all starts with this. You might remember this certain kind of equation of a line. It's called the slope-intercept form of an equation. Okay? Now, this isn't the same to be confused with the slope formula, which is how you find the slope given 2 points. This is the slope-intercept form of a line, which you see right over here. Now, the special thing about the slope-intercept form of a line is this. When you look at a slope-intercept form, there's some very good information you get from it. The first is you can find the slope. All right, you get the slope from it. That's the number in front of the x. That's the slope. The number over here that doesn't have an x is called the y-intercept. And if you forgot that, what that is, that's where the line intersects with the y-axis. Remember that? That's what the y-intercept is, where the line touches the y-axis. But the big thing to this whole thing that you really have to take note of is that for it to be in slope-intercept form, y has to be by itself. Y must be by itself. If y is not by itself, then it's not in slope-intercept form. All right? Now, so if you look over at this question, determine the slope of the line y equals 2x plus 5. All right? We got this right here. It's pretty straightforward if I ask for the slope because it's just the number in front of x. Y is by itself, so it's just going to be 2 for our slope. You know what? Let's throw in the y-intercept here. Let's go crazy. The y-intercept is 5. And if we were to just draw a rough graph of this, it would look something like this. You'd have the y-intercept at 5 right over here. And then you'd just go up 2 over 1, and you draw your slope, okay? And that would be your line, okay? Remember, this is your y-intercept right here, and then the slope would be up 2 over 1. But that's nice and easy because that is already in slope-intercept form. What we're going to be talking about today is how to find the slope when it is not in y-intercept form. Slope-intercept form, and how we can get it into that. So let's get into it, okay? So we have 3 examples here, and we're going to find the slope of all 3 examples when it is not already in slope-intercept form. I know, I said it. I'll stop repeating myself. Let's go. So for this first one, you'll see we have 4y equals 6x plus 20. Now, the problem here is this. If you look very carefully, we got that stupid 4 there. So y is not by itself. And if y is not by itself, well, guess what? We got to get it by itself. So we are going to solve for y. And a way to do that is this. Just drop a line down, okay? We're going to put y on this side, and we're going to put everything else on the other side. So always put E here, E to kind of represent everything else. So what we got to do to get y by itself is we're going to have to move the 4 over. And the way you move the 4 is, you might remember this, inverse operations. So the inverse operation here is this. This is 4 times y. So the inverse operation of multiplication is division. So we're going to just divide all this by 4. So we're going to divide this by 4, we're going to divide this by 4, we're going to divide this by 4. And when we do, we can bring everything down, and we get y, because this cancels out, is equal to, and if you put 6 over 4 into the calculator, you'll get 1.5. But we want to leave it as a fraction, so we're just going to leave it as 6 over 4. So we get y is equal to 6 over 4x plus 5. So you might be looking at this and say, hey, well, now y is by itself. All right, it's all by itself, so we know the slope is 6 over 4. But you are not done because there's an important key point here. And I'm going to write this also for you. You must always, and I said this last time, you must always reduce your fractions. You got to reduce that fraction, okay? You can't leave it like that. So 6 over 4 is reducible. We're going to rewrite that as y equals 3 over 2. We just divide the top and the bottom by 2, x plus 5. And that is our final equation. So to ask me now, what's the slope? Well, it's 3 over 2. So we had to get y by itself before we could answer that question, and now it becomes nice and simple. let's try some more examples, okay? So if we go on to our next one, once again, you're looking here, and y is not by itself, right? We got all this stuff, other stuff, on the left side of the equation. So we're going to get y by itself. So I'm going to put y on this side, because I already got my y there. And I'm going to move everything else to the other side of the equation. Now to do that, I'm going to start by moving the 4x. All right, the way I'm going to do that is, since the 4x and the 2y are kind of being added to each other here, I'm just going to subtract the 4x to the other side. I'm going to subtract 4x from both sides. All right, first move the 4x. You can cancel the 4x's out. We're going to bring down 2y, and we're going to say, well, what's 6 minus 4x? And you might remember that these are not like terms, and you can't add terms that are not the same. This has an x, this doesn't, so they're not like terms. So it's actually a lot easier. We're just going to bring down the negative 4x plus 6. So I just brought both of them down. Now y is still not by itself. We got that 2 there. So once again, we're going to just divide everything by 2 to get y by itself. And we get y is equal to negative 2x plus 3. And this is looking pretty good. That is in slope-intercept form. My y is by itself. Everything looks good. Fractions don't need to be reduced, so my slope is negative 2. And for our last example, this is my new suggestion here. Try doing this last question by yourself, all right? And if you got that, and then come back and check it. So I'm going to say pause the video and see if you get it right. So pause the video now. And now you should be coming back, and we'll do it together. So what you should do is drop the line down. Okay, we got y on this side. Everything else got to move over. Now watch very carefully. There's a lot of things that can go wrong. First, we're going to subtract 8x from both sides. All right. When we do that, we get negative 10y is equal to, and remember, these are not like terms, is equal to negative 8x plus 20. All right, we just bring them both down. Now, I just want to be clear here. Something really important happened, and a lot of people miss this. If there's a negative here, you got to bring the negative down. The negative is important there. You got to keep it with you. And that negative is going to play an important part. So watch what happens now. So the next part of solving is we're going to have to divide everything by negative 10. All right, we got to keep that negative going here. So if there's a negative, you bring it down. So we divide everything by negative 10. On this side, it just cancels out. And this side, when you have two negatives, a negative divided by a negative, it actually makes it positive. So we get 8/10. And the reason I'm keeping it as 8/10 is because if you put that in the calculator, you get 0.8. So that's a decimal. So it can't be reduced. I mean, it can't be, well, we're just going to leave it like that. It comes out as a decimal, minus 10. Because 20 divided by 10 is minus 10. And now, since we're looking at this 8 over 10, we say that can be reduced. So we're going to finally reduce that. And we get 4 over 5x minus 10. And that is the final answer. And if you got a negative there, you probably didn't bring this negative with you. All right? The negative is so important. Don't forget that. Track your negatives. They're very important. And so the slope here is positive 4 over 5. And those negatives, I can't... those negatives is where most people make their mistakes. So I really want you to pay attention. Bring down your negatives. Be a good student. Be careful. Math's about precision. Okay, so we can find the slope. Let's try graphing some lines here, okay? So for our first one, let's just start with basic graphing. Now, you might remember how to do this. You might not, but I'll just remind you. So if it's already in slope-intercept form, which it is here, you have your slope, you have your y-intercept, and what you do is you take your y-intercept, and this is where you start graphing. You're going to start graphing here, all right? We're going to start with this point. So this is where we're going to start graphing. So we go to 4 on the y-axis, and that's our first point. Now we're going to use our slope, and we're going to go up 1, because it's rise over run, up 1 and over 3. And that's where you put a point. And you just keep doing that, up 1 over 3. And that's where you put another point. Now, some people say, can you go backwards? You can, but just remember that you got to change it up. So you're going to go down 1, and that's to the left 3, because you're doing it the opposite way. And that's the other point. And once you get about 3 or 4 points or so, you draw a nice little line through. Hopefully you're using a ruler. And I'm not saying hopefully. You should be using a ruler. You get a nice, beautiful line such as this. So this is y equals 1/3 x plus 4. Okay, so let's try another example, but this time, guess what happens? It's not in slope-intercept form. So if it's not in slope-intercept form, then you can't automatically graph it. You got to put it into slope-intercept before you graph it. And luckily, we just learned how to do that. So let's put this guy into slope-intercept form. We're going to drop our line down. We're going to put our y here and everything else on the other side. And let's just start moving things over. So that 2x, we know we got to subtract. We got to subtract 2x on both sides. And we'll get 3y is equal to negative 2x minus 12. And once again, that negative has to come down. It's negative 2x comes down and negative 12. Now we're going to divide everything by 3. We get y is equal to negative 2/3 x minus 4. And that, my friends, is how you get into slope-intercept form. But we're not done. We got a graph. So once again, remember, this is where you're going to start graphing. So you're going to start graphing at your y-intercept. And so since it's negative 4, you put your first point at negative 4. Okay? Now, let's do it. So our rise is negative 2, so that means you go down 2 when it's negative. Okay? Negative 2, and then over 3. So that's our next point. We're going to go down 2 more, over 3, and that's our next point. All right? We're going to go in the other direction too. We'll go up 2 over 3. All right. Now we're going to draw a nice line. Woo, bang. Looking good. And that, my friends, is how you draw this beautiful, beautiful line. And once again, please use a ruler and label your graphs. It's just good habits. And then finally, we got this guy right here. And what I'm going to say is this. Why don't you try doing this by yourself? Try solving it and graphing it and come back and see if you get the answer. Okay, I'm going to pause the video now. What I'd like you to do is solve it yourself. Come back and we'll check to see if you got the right answer. Pause the video. No. All right, if you've done this correctly, what you first started by doing was adding the 8x over. And I know you didn't see that coming because the 8 is usually on the other side. We usually see this reversed. But first we did was we added 8x to both sides because we want to get y by itself, so that's why we moved the 8. We got 6y equals 8x minus 24. We divide everything by 6, and you should have gotten y equals 86x minus 4. You saw that this could be reduced, and so you did. Y equals 4/3 x minus 4. When you graphed it, you started at negative 4 because this over here is your starting point. And then you go up 4 over 3. And that is how it's done, yo. We've mastered it. All right, guys, that's it for this one. So what I suggest doing right now is go finish out your independent practice, then go up to your mom. Just sit right beside her for a little bit. And when she looks over, you just say, hey, Mom, you know you're the best mom in the world. And then give her a little kiss on the cheek and high five her. All right? And she'll appreciate that. And you might get a little extra soup for dinner or whatever it is that you eat. But my mom used to make me soup. You know what? It's getting too personal. I got to get out of here. Bees.